Hi, everyone. So I know this is the worst time of the day for you to listen to a keynote because the ramen and the tonkatsu you just had during lunch is now coming into your blood. You're feeling really dizzy. I promise you, if you give me 15 minutes, you're going to be going home with something very interesting. So my name is Jerry Yan. So I'm the general partner of the Hardware Club. One thing I want to note is that despite the name, I did not co-found Yahoo, so that's very, very obvious. Otherwise, I will be in the first session in the morning and not in the afternoon. Okay, so we managed to fund, the fund size is about $50 million US. We invest mostly in early stage hardware startups in Europe and in US. So my topic today is the bottleneck of AI. And so I think AI is one of the buzzwords that every now and then people just get it out and just talk about it, invest in it very often. We VCs are looking for contrarian views, right? So things that are different from what the mass market was thinking. One of the interesting things is that people have been talking about AI from the software point of view as if that would solve everything. And people have been wondering why we're investing why we're investing in hardware and what does that have to do with AI? And so this is the share price of 5 stocks on the market. So this is a public company over the past 5 years, okay? And so the vertical axis over there, you'll see that that's the percentage of the up. So you see that some of the stocks in the bottom, they appreciate about 59% or like 131%. And the one on the top, the best performing one, the share price go up 16 times. So you make 1,500% of return over the past 5 years. So why 5 years? So 5 years is also happened to be the time when the whole AI thing started to happen. So the modern AI is about machine learning running on different kind of hardware solutions. And so the ImageNet large-scale video recognition sort of contest is the one when it first started. In 2012, that's the first time the deep CNN actually broke, I think it was 16% error rate. So it started to have some error rate that makes sense. And it go down to like 7% very quickly. And in about 2015, it beat human beings in image recognitions. Most of the human beings will be recognizing images with a 5% accuracy. And the deep CNN can actually beat that and with a 3.6%. And that's where you see started to have like all the investment in AI happening, right? And so these are the 5 stocks. If you're going to pick 5 stocks, 5 years ago when you first recognized there's an AI age coming, and these are all public companies, very big ones. I'm not picking some small ones trying to trick you. So each one of them is more than $100 billion market cap. What would be the companies driven by AI that you believe would be the most successful? It's kind of difficult to do Q&A here, but I guess you probably have Google, Facebook in mind, right? So let's start with the ones in the bottom. So they still make, the share price still make you quite some money. The lowest one is Google. So it appreciated by about 59%. Then Apple, with the Siri and the chip in the phone. Facebook. Amazon, with Echo, with auto voicing. Which is the company that benefit the most from the AI boom? If you want to make return. Anyone here doesn't know the company? NVIDIA. So that's the company, very, very old company created by another fellow Taiwanese in Silicon Valley that is the dominant supplier of something very, very boring, but that has become the lifeblood of all the AI companies today, the GPUs, the graphic processing units. If 5 years ago you were smart enough to recognize there's an AI boom coming and you're public market investors, not a VC, so you're investing in public stocks, you would have picked, probably most of them would have picked Google, Facebook, or Amazon. But it was NVIDIA appreciated most. And it went up by almost like 16 times. The market cap today, I haven't checked yesterday, but I think it's around $200 billion right now. So why is that? Why is that? You don't really think that that's gonna be the startup appreciated most due to the AI boom. Why is that? It's not even that they were going down and they're coming back, so that's why there's a big appreciation. No, they've been doing fine with selling GPUs to gamers. And this is my topic today. So the reason that happened is many people didn't realize that the AI today is still mostly constrained by the computation. So there are a couple problems with the computation today. I'm going to skip this one and jump to this one. So there are a lot of constraints that the software developers didn't really pay attention to until they start to try to monetize their AI application and realize they will never make money. And they all come from hardware. So the first thing is that we still don't have the throughput in computation, enough throughput in computation to do AI inference effectively. So you're paying a lot of money just to get something very simple done, even if you believe it's a software solution, but just because you need a very powerful hardware to do that, it's very difficult. Second, there's always the memory issue. So the memory issue is linked to the energy consumption issue. So most of the computation today, whether it's GPU or CPU, most of the people here probably don't know, every 1 watt of power you burn, 60 to 70% are not used in computation. They're used in moving the data around. Move it from the disk to the DRAM, from the DRAM to the CPU or GPU, and move it back. So you're burning a lot of power not doing computation, just moving the data around, right? And so that would generate heat, which is an issue if anyone of here ever been to a data center, there's a huge issue that data centers have to cope with, and which lead to problem of sustainability, and obviously there's also other things, and the cost. So I'll give you one example. So we all recognize this game now. So this is also one moment where AI is coming, right? Human beings are going to die, that kind of thing. So this is a game that Google AlphaGo beat Lee Sedol, the #1 Go player in the world back then. They used 250 GPUs, 2,000 CPUs. Guess how much energy that requires to run this system? 300,000 watts. And the guy on the right, Mr. Lee, you use one brain, it burns about 30 watts. Human brains are still by far the most energy efficient mechanism that we have ever tried to understand on this planet. Okay, so there's a huge disparity. So if you're doing some AI application and you're thinking, oh, we can replace human beings with that, first look at this. Can you handle this energy efficiency and still make money out of it? And the reason for that is, I'm going to go through this very quickly. This is courtesy of Google, so you can find it on their website. The reason is because the traditional computation architecture, if you look at CPU, you see that it's moving the data bit by bit from memory to computation, and then at some point you get the result on the right, right? So you see a lot of movement of data, computation is happening very fast in the upside. So you spend a lot of energy and time just moving the data. GPU is much better, so you have a lot of small computation unit with their own small memory on chip. And you move the data all at the same time, and at the parallel phase, you can move everything to the output. But still, that's a lot of memory and moving data inside and outside. The TPU that Google announced 2 years ago, and now they're in all the data centers that they have, every time you send a command through Google image recognition, they run through the TPU today. And they just open this up to programmers to use it. So the way it works is that it's designed for specific machine learning types that Google is doing, which is image recognition and voice recognition. And the way it works is that they basically do the computation alongside, so you don't do extra memory, you just do the computation alongside, just pass the result to the next stage of computation without putting into any kind of intermediate memory. And that's also faster and more energy efficient. But you didn't see the stock price go up 16 times of Google, so apparently that's still not the solution today, right? And this is a Google TPU picture photo. What do you see? You see a beautiful photo with like thousands. What do you see when you first see this one? Do you see the copper color sort of thing? Anyone knows what that is? That is the heat sink. So those coppers, so you can do a very complicated chip, but you need those coppers to bring the heat out. Otherwise, the chips will burn out. So think about that. So if you remember the previous slide when I talked about you need 200 GPU and 2,000 CPU to run the whole thing, it burned 300,000 K. That's what I mean. Look at all the things you do, fantastic thing you do. You have to bring those heat out of the server and then out of the data center, right? And then to bring that out, you also need more energy. So there's a problem that has to be resolved. Okay, so that's why a lot of the VCs pump money into AI hardware startups. So those are about 500, 600 million worth of money that went into AI chip startups, just the chip startups, not the alternate computation. So you see web computing with Samsung, Cerebral System with Benchmark, Blackpool invested, based in Bristol in Europe, invested by Sequoia, Sembanova System by Google Ventures, Mythic, based in Austin, Texas, got money from SoftBank Ventures. And you see 3 Chinese companies that each one of them receive about 100 million just doing AI chips. Okay, this is just the start. It's not, we don't yet have the solution. Another problem is also, so this is the co-founder and CTO of Nirvana Systems that got acquired by Intel. So they're one of the first full-stack AI solution company, and they're now the main AI team inside Intel. So Amir said last year in the IEEE symposium that everyone is doing CNNs, so convolution neural network. And that is tragedy. Don't assume anything going on would be there in a year. So which means that if you're designing a chip or hardware solution, which is very important, but you're trying to do that, like Google TPU, to adapt to a certain algorithm, chances are algorithms are evolving faster than what you can do, right? So a year, 2 years later, there's a better algorithm, you have to redo the whole thing over again. Okay, so that's also a challenge that I don't think none of those players in the previous slide really realize they're faced with, right? So these guys, they've been there, done that solar company to Intel, and they're solving that problem now inside Intel as the AI department. They know it's not there yet. And there's also another problem where, what if you have to do it in the field? So we talk about edge computing. So Masayoshi-san bought ARM, having the dream that eventually ARM core will be in all the sensors in the field, in the forest, in the mountain, and then you'll have the sensors plus the processing power and intelligence. But how do you power it? It's in the field. You cannot recharge it. You cannot. So the only thing you can do is energy harvesting, right? So you do solar panel, you do vibration, you do the temperature difference sort of harvesting. And those generate very little power. And so you need to have a system that can run on the edge, that provide the AI intelligence, but still can run on very low power. So that's another issue that we have to deal with before we reach the AI nirvana. And there's another sensor issue that happened in the Uber accident. So this is the picture of Uber's car the day after it killed a passenger, actually a biker, coincidentally. So the report of the police officer is that the 49-year-old victim came out of the shadows right into the roadway. What is this problem? Is it a computation problem? Is it a software problem? No, it's a sensor problem. You see, the sensors cannot cover such a dynamic range. So from very deep, dark shadow, anyone of here do digital imaging, you know, digital cameras. You have deep shadows that human beings can see, but cameras cannot see at the same time as the bright sunlight or the bright spotlight that you have. And your sensor get full, so you can have the best autonomous driving algorithm, and your car will still kill people because the sensor don't see that. And that has to be resolved as well before you have all those. So I think I will sum up my whole talk just by one thing. It's wonderful that we have so much resource and so many people devoting into AI. And the top tier AI investors, VCs are now recognizing that you have to put money into the hardware as well, but the hardware is not there yet. You have to put in a couple of years, like $10 billion into AI software companies. But we're not there yet. If you're developing an AI application and you're still prototyping, you might imagine that by the time you roll out the service, it would make money by itself. But all those costs, you have to pay for it. The money you're paying to Amazon today for AI inference, the reason it's not the price you like is because they're paying for the GPUs and everything else, and the electricity, the cooling system, and all that. That money will not go away. Nobody is going to give that to you for free. And so if your AI solution is not solving something that is worth solving using a current AI system, it's better that you wait until a better hardware system comes out, right? And so this sums up my talk. So I have my email address there. It's very simple. It's jerry@hardwareclub.co. So if you're doing a hardware company, any kind of like hardware-related companies, full stack all the way to the cloud, feel free to drop me a line. I'm happy to talk to you. Thank you very much.